Okay, Bismillahirrahmanirrahim. Assalamualaikum and hi guys. Okay, so for today's lecture, I will continue with 2.4 part D, which is we can determine the volume of a solid of revolution. Okay, so basically the volume is divided into two cases. Okay, which is the first case, we can have a curve or region between two curves that rotate or revolve through x-axis, and then another one would be a curve or region between two curves that rotate through y-axis. Okay, so let's go through the x-axis first. Okay, so let's say I have a curve over here, a curve or a function, and I label it as fx. Okay, and the limit is from a until b. Okay, so if this curve or this function is rotate through x-axis, it will actually become a cylinder shape. Okay, it will become a cylinder shape. So how do we find the volume of this shape? The formula is this, which is pi, the lower limit a and the upper limit b, which makes sure that the a and b is the value of x, and then the curve square. Okay, this is the formula. So how about if we have two curves, the region between two curves? Okay, so for example, we have this region over here, okay, which is we have the shaded one. So now let's say this curve rotate through x-axis. Okay, rotate through x-axis from a until b. So what is the formula for the volume? Okay, the formula is actually this: pi from a until b, atas square tolak bawah square. Okay, remember from the previous lecture, the x involve atas dan bawah kan, so same as volume, but the difference is we can have pi and we're gonna have square for both function. Okay, so based on this, now we're gonna see what the formula is. So daripada atas, kita akan sentuh function ni dulu, which is this is fx. So you put fx square over here, and then minus function bawah adalah function yang ni, which is gx square. So this is the formula for this. This is the formula for the volume of the region. Okay, using this. Okay, now moving on to curve that rotate through y-axis. Okay, so let's say I have a curve over here and I'll label it as fy. Okay, and then we have lower limit, let's say c, and the upper limit would be d. Okay, so let's say this curve or this function rotate through y-axis. Okay, so it actually will become a cone shape. So the formula to find the volume of this shape is this: pi from c until d, and the function square. Okay, and make sure this function must be in term of y, because we use dy and the limit is the value of y. Okay, and then for the region between two curves, again, as mentioned from the previous lecture, kalau area yang pakai dy, the formula would be kanan tolak kiri. So same as volume, but different is we're going to have pi and we're going to have square for the function. Okay, so let's say this is the region that we want to find. So let's say this region rotate through y-axis. Okay, so what would be the formula? So based on the formula here, we can use dy since it's rotate at y-axis, and then the limit must be value of y as well. So the formula is kanan square tolak kiri square. So from kanan, kita akan jumpa this function first. So this is fy. That's why fy square over here, and then minus kiri. This is the kiri one, just gy square. Okay, so this is the formula for this volume of region using the formula. Okay, so that's it. That's the formula for volume of solid of revolution. Okay, now let's do a few examples. Okay, so for example 20 number 1, the question asks us to find the volume of the solid of revolution formed by revolve the graph of fx about the x-axis. Okay, so from this problem or from this question, we already know we're going to use the dx formula. Why? Because it's already mentioned that the solid revolve about the x-axis. That's how we know we're going to use the formula dx. Okay, so now let's draw our graph. So we have this graph. This is quadratic graph with the set shape, and then plus 4. So 4 as the y-intercept. So it will look something like this. Okay, so I label my function. So this is fx 4 minus x squared. Okay, so now let's find the y-intercept. Okay, so the y-intercept is when x0. So when x0, it will become 4. So now let's find the x-intercept. So x-intercept is when your y is 0. So 0 equal to 4 minus x square equal to 4, x equal to plus minus 2. So here 2, here negative 2. Okay, so it says that the graph revolve about the x-axis in the first quadrant. Okay, so we have 4 quadrants. This is number 1, this is number 2, this is number 3, and this is number 4. So obviously the first quadrant will be this here. So the region is actually over here. This is the region. Okay, and it can rotate through x-axis. Okay, so what's the formula? So based on the formula given, so now the volume would be pi. So our limit is from 0 until 2. Make sure they are value of x. And then the formula would be fx squared. Okay, because we involve only one curve, which is this one. So now I substitute the curve, which is 4 minus x squared, and then we need to square that. Okay, so now we cannot directly integrate this one because this is quadratic inside, so we're gonna need to expand. 4 minus x squared, 4 minus x squared dx. Okay, so now I'm gonna expand it. Becomes 16 minus 8x squared plus x to the power of 4 dx. Okay, now you can integrate. Becomes 16x minus 8x cubed over 3 plus x to the power of 5 divided by 5. So the limit from 0 until 2. Okay, now substitute your upper limit minus substitute your lower limit, and the final answer would be 256 over 15 pi unit cube. Okay, so this is the final answer. Okay, so now for number 2, you can try by your own. So I'll give you the final answer. You can try by your own. So now let's do number 3. So the question asks us to find the volume of the solid obtained by rotate the region bounded by this one, and x equal to 0 about the y-axis. Okay, so based on this formula, based on the question, we know that we're gonna use dy. Okay, the formula dy. Why? Because it says that the solid rotate about the y-axis. That's how we know we're gonna use dy formula. Okay, so now let's draw the shape of the graph first. So we have x cubed. So our x cubed will be something like this. Okay, and then we have x equal to 0. So this is x equal to 0. Your y-axis is x equal to 0. And then y equal to 8 is somewhere over here. This is y equal to 8. Okay, so now let's find the area first, the region first. So the solid must be region bounded by this, and this. So I'm going to use the highlight. So bounded by the curve, bounded by y equal to 8, and bounded by x equal to 0. So the region would be here. And it will rotate through y-axis. Okay. So the volume is equal to pi. So from C until D, so from 0 until 8. So the formula involves only one curve. Okay. So Fy squared dy. Okay. So since we use dy in this case, we must make sure that our function must be in terms of y. So we need to rearrange this equation. I cube root both sides, so it will become cube root y equal to x. So x equal to y to the power of 1 over 3. So we're gonna put y 1 over 3 over here, and don't forget to square. Okay, so multiply the power, will become 2 over 3 dy. So now we can directly integrate, become y to the power of 5 over 3 divided by 5 over 3 from 0 until 8. Okay, so you substitute the upper limit minus substitute the lower limit and get the final answer, 96 over 5 pi unit cube. Okay. Okay, now moving on to next example, example 21, question 1. So they ask us to find the volume generated by revolve the region bounded by this and this through x-axis. Okay, so for this question, it says that the volume generated by revolve the region through x-axis. So that's how we know we're gonna use the dx formula. Okay, so I already draw the graph for you. So we have this one, the blue one, and then we have the green one. Okay, so now let's find the region that is bounded by these two curves. Okay, region that bounded by these two curves. So again, I'll use my highlight to see more clearly which area or which region would be. Okay, so from this, notice that there is one small region that is bounded by the two curves, which is over here. This is the region. Okay, and the region gonna rotate through x-axis. Okay, so we're gonna use the formula dx. Okay, but the question would be, what is the limit from where until where? Okay, so we need to actually find the limit. Let's say I label it as A and B, so we need to find the limit in order to find the volume. Okay, so let's find your your A and B. Okay, so this is actually intersection points, right? So we have intersection point and we can find it using the simultaneous equation. Okay, so we're gonna need two equations. So the first one would be this, second one would be this. So y equal to x plus 3 over 2, this is number one, and we have y squared equal to 4x, and then this is second equation. So I subs 1 into 2, so x plus 3 square equal to 4x. Okay, so I expand x squared plus 6x plus 9 over 4 equal to 4x, and then I'll multiply to the other side, becomes 16x, so x squared minus 10x plus 9 equal to 0. So factorize using the calculator, we're gonna get two factors. First one is x minus 1, the second one is x minus 9. So we have two values of x equal to 1 and x equal to 9. That's how we get our A and B, 1 until 9. Okay, so for this question, we're gonna use the formula atas square tolak bawah square. Why? Because it involves two curves. Only but can do a curve. Okay, this one and this one. Okay, so the formula would be atas square tolak bawah square, and it must be in terms of x. Okay, so daripada atas, kita akan jumpa the green one first. Okay, the green one first. So the green one first. So first, let me write the formula first. Okay, I do it like this. Okay. Okay, so first, our fx square or y square is this one. This is already square, so you don't need to square again. So you just put it like this. fx1 square is y square. So this is your y square. You already get 4x, so no need to do anything with that. And then for this one is function bawah square. So yang bawah adalah the blue one. So for the blue one, you need to substitute your y, but you need to square it. Okay, because it doesn't have square over there. Okay, so you need to manually square it. Okay, so now let's solve this integration. But before that, the power 2 belong to numerator and also denominator. So I write it like this. So now we can directly integrate. So 4x squared over 2 minus the power plus 1 divided by 4 and also 3. 4 divided by 2 is 2. From 1 until 9. Okay. So for the last step, substitute your upper limit minus lower limit, and then the final answer would be 64 over 3, and don't forget your pi over here. Pi unique cube. Okay. Okay, so for the last part of this video, we're gonna solve the question number 2. So they asked us to find the volume when the region bounded by this and this is revolved through y-axis. So again, we can directly know which formula to use, whether dy or dx. The answer would be dy. Okay, why? Because it says the region is revolved about y-axis. That's how we know which formula to use. Okay, and then since it involves two curves, we can use the one kanan square tolak kiri square. Okay, so I already draw the graph for you. Okay, so now we gonna straight go to the solution. Okay, so let's first find the region first. So it says that the solid is when the region bounded by this and this. Okay, so again, I'm using my highlight. Region bounded by the purple one and the green one. Okay, so I believe everyone already see which part of the region is bounded. So this is the one. And it gonna revolve through y-axis. Okay, so we're gonna use formula dy. Okay, so pi from C until D, kanan square tolak kiri square, or fy1 square tolak fy2 square dy. Okay, so now let's first see the limit. So the limit must be a value of y. So notice that this is C and this is your D. So this is your C and this is your this is your D. Okay, So again, how do we find this point? This is actually intersection. So again, we're gonna find the limit using simultaneous equation. So now for this case, we will find C and D. Okay, so we're gonna need two equations. So the first one is y squared equal to 4x. This is equation 1. And we have y equal to 2x minus 4. So I rearrange this equation to get x. Y plus 4 over 2. So this is second equation. So I subs 2 into 1. Okay, so y squared. So into 1. So y squared equal to 4 multiplied with y plus 4 over 2. So 5 divided by 2 is 2. So y squared equal to 2y plus 8. So y squared minus 2y minus 8 equal to 0. So using the calculator, we're going to have two factors, y plus 2 and y minus 4. So the value of y will be y equal to negative 2 and y equal to 4. Okay, so we already get the value of C and D, which is it will become from negative 2 until 4. Okay, so now we're going to insert the function. So that based on the formula, dikata daripada kanan square. So kanan square. So we touch this one first, the green one. Okay, so since we use dy, the function must be in terms of y, right? So we need to rearrange this equation, okay, to get the x. So y plus 4 over 2 is your x. Okay, now substitute y plus 4 over 2 square minus. So now the key ring one would be the purple one, this one. So again, since this is dy, we're going to need to find the x to make sure that the function over here must be in terms of y. So again, I rearrange the equation. So become x equal to y squared over 4. Okay, so substitute into the formula. Y squared over 4 squared. Okay, so now I'm gonna square numerator and also denominator over 16. Okay, so now we can directly integrate. Okay, so the first one become y plus 4 power 3. 4 multiply 3, and this one y minus 5, and 16 multiply 5 is 80. Okay, so your lower limit is negative 2, your upper limit is 4. So again, substitute your upper limit minus substitute your lower limit, and then the final answer would be 144 over 5. And don't forget to write your pi back. Unit Q. Okay, so this is the final answer. Okay, so that's it. That's it for volume of solid revolution. So you can try by your own the example that I'll leave for you to do, and also tutorial questions. Okay, bye guys.